Okay, this section is chapter 4, section 3, and we're still talking about polynomial and polynomial functions, but we're going to have an introduction to factoring. So we're going to factor polynomials whose terms have a common factor, and we're going to factor certain polynomials with 4 terms by grouping. To factor a polynomial is to express it as its product. A factor of a polynomial p is a polynomial that can be used to express p as a product. A factorization of a polynomial p is an expression that names p as a product of factors. So, if we want to factor 9 times m squared minus 27, we can look at both of these terms, and we would want to say, well, do 9 and 27 have anything in common? In other words, can I divide 9 by something that I can also divide 27 by something? And the answer to that is yes. We can divide 9 by 9, and we can also divide 27 by 9. So we want to pull the 9 out of both of those numbers. So if we take the 9 out of 9m squared, we would just have 1m squared. If we take the 9 out of minus 27, okay, we would pulling out, we're just leaving the minus there. We pulled out the 9, and 9 times what gives us 27? Well, the answer is 3. Now if you'll see that they took these two things and they grouped those together, and we've got 9 times m squared minus 3. Okay. The next example says to factor 25 x squared y to the 5th, 35 x to the 6th y to the 3rd, minus 15 x to the 3rd y to the 4th. The first thing that I like to look at is your numbers in the front. 25, 35, and the 15. Just kind of ignore the minus right now. And the immediate thing that I see with all of those is that there's a 5 in each one of those, okay? And so if I take the 5 out of 25, 25 divided by 5 would leave me with 5. 35 divided by 5 would leave me with 7. 15 divided by 5 would leave me with 3, okay? And that's how they're coming up with this 5 and 7 and 3 down here. The next thing that they're looking at is their variable. And so they're kind of comparing this x squared right here to this x to the 6th to this x to the 3rd. Now you can only pull out the smallest of the 3 things. So if we've got an x squared and an x to the 6th and an x to the 3rd, the x squared would be the smallest. So they took the x squared out of each one of these terms. Well, if you take x squared out of x squared, you don't have anything. Okay, so far we pulled a 5 out and we're pulling an x squared out. We would be left with nothing here. But if you take an x squared out of x to the 6th, remember that you're subtracting the exponents here, so that's going to be x to the 6th minus 2, which would give you x to the 4th. And if we took an x squared out of x to the 3rd, it would be 3 minus 2, which would just give us x to the 1st. Okay, now if we look at our y values, we've got a y to the 3rd, a y to the 5th, and a y to the 4th. Well, the smallest among those 3 is y to the 3rd, so I can pull that y to the 3rd out. If I pull a y to the 3rd out of y to the 5th, 5 minus 3 would be y squared. If I pull a y to the 3rd out of y to the 3rd, I don't have anything there. If I pull a y to the 3rd out of y to the 4th, 4 minus 3 would give me y to the 1st power. Okay, now if you'll look down here, they've got their answer. 5x squared y to the 3rd, okay, which is what we pulled out in the front. 5x squared y to the 3rd up here at the top. okay? And then they've got what's left, the 5y squared plus 7x to the fourth. So the 5y squared at the top, 5y squared, 7x to the fourth, and then 3x squared 3x to the first y to the first. And they pulled down their minus sign. So that's how they're coming up with the stuff that's left there. Polynomials that cannot be factored further are said to be factored completely. The factors in the resulting factorization are said to be prime polynomials. When the leading coefficient is a negative number, we generally factor out a common factor with a negative coefficient. So for example, write an equivalent expression for negative 4x squared minus 16x by factoring out a common factor with a negative coefficient. So it looks like what they've done is they've got notice that the negative 4x is the largest factor. So they're going to pull that negative 4x out of, they're going to pull negative 4x out of negative 4x squared and out of negative 16x. Let's think about that. I'm going to kind of divide this into two things. If I take a negative 4 out of negative 4, right? If we take negative 4 out of negative 4, we don't have any numbers left. It would be just negative 4 times 1. If we take an x out of x squared, we're still left with an x, because x times x squared is going to, x times x would give us back our x squared. If we take a negative 4 out of negative 16, well, this is going to need to be a 4, so that negative 4 times 4 would give me negative 16. Now, if I take an x out of negative 16x, I wouldn't have any x's left. Okay, so if you look at their answer, they've pulled the negative 4x out in the front, and then they've grouped the things that are left, which would be our x and our 4, so x plus 4 would be the resulting answer of that. In expressions of 4 or more terms, there may be a common binomial factor. Often, in order to identify a common binomial factor, we must regroup into two groups of 2 terms each. Okay, so here's an example. They want us to factor x plus 4 times m plus x plus 4 times y minus b. If you'll notice here that these two are exactly the same. So we actually can pull those out front and group those together. Then they've taken their other terms, the m and the y minus b, and they wrote m. Since this is a positive, right, plus y, plus positive y, and then our minus b, and they group those things together. In order to do this, though, we have to have two things that are the same. There would have to be x plus 4 times x plus 4 right here. Okay, now, it says to factor y to the 5th plus 5y to the 3rd plus 3y squared plus 15. Okay, so this is called factor by grouping. So the first thing that we're going to do is we're going to group these first two terms together. This is why they did that in parentheses. Then they group the last two terms, which is why they've got this. Right? They just grouped them together. Then they looked and they were like, well, what do both of these two terms have in common? I can't pull any numbers out because this is just a 1y to the 5th. But I can pull out a y to the 3rd because both of them have a y to the 3rd in it. So they took a y to the 3rd and pulled it out front. If you take a y to the 3rd out of y to the 5th, 5 minus 3 would be y squared. If you take a y to the third out of y to the third, you would have no y's left. So they've got y squared plus 5 here. They've done the same thing with these two terms. They looked at this and said, well, we could take a 3 out of 3 and out of 15. So if you take a 3 out of 3, we would only have the y squared left. If we take a 3 out of 15, we would have 5 left. And remember that when you, if you want to check yourself, when you multiply these back out, you should be able to get what you had in the first place. So y to the third times y squared is y to the fifth. Y plus, or y to the third times 5 is 5y to the third. 3y times y squared is 3y squared, and 3 times 5 is 15. And now they have taken, since both of these are the same, they grouped them together in the front. Then they took our y to the third plus 3, and they put those two together in the back. Okay, we have another example. And so we've got 3x minus 3y minus ax plus ay. So the first thing that we want to do, and they've kind of skipped this step, is they want to group these together. Okay, so when they did this, now you've got to be careful about this last part, but we'll talk about that. They looked at these two and they said, well, they both have a 3 in front. So they pulled out a 3, and what I would have left would be my x minus y. Okay, and so on this one, they looked at both of these terms and they said, well, they both have an a in them. So they pulled the a out front, and so we've got minus a, and then we've got an x and a y left. But what you need to remember is that you've got to make sure that when you multiply this, we get back with what we started with. And so negative a times x, that would give us our negative ax. But this negative a times negative y, we need to have a positive ay here. So they've grouped these two things together, 3 minus a, to get 3 minus a. Then they've got their x minus y times x minus y and grouped those two together. Okay, one more example. I'm going to start from the beginning. So this says no matter how we group these terms, there is no common binomial factor. So in other words, when we start playing around with this one, when we start grouping things, we could do like this, and we could do this. Okay, and when we do this, we could pull out an x squared out of the front, but that would leave us with x plus 2. If we take an x squared out of both of these terms. And in the back, I could pull out a 2, and that would leave me with x minus 2. Well, the problem here is that we've got an x plus 2 and an x minus 2. And so that's going to give us a little bit of a problem. We're not able to put those two things together because of that. This is kind of a tricky topic. If you need more videos, don't forget to watch like the videos that are attached with your My Math Labs if you're really struggling with this. And I'll be working some other examples in class as well.